what are the insights in your experience you have been able to, glean from those numbers that you have got? Can you just discuss briefly on that?
Absolutely, Nitin. So, you know what? The best part is Crisp MLQ gives a concrete framework to handle the project step by step. And as part of exploratory data analysis, we perform univariate analysis. Uni means single variable analysis. We perform bivariate analysis, which is with two variables. And we also perform multivariate analysis. And when it comes to univariate or bivariate or multivariate analysis, first we need to look at whether the variables that we are dealing with have numerical values or do they have categorical values. If you have categorical values, there's nothing much that we can glean from the data. And hence we keep saying that nominal data is the least preferred data. So we need to basically look at numeric data, and from that you can glean a lot of meaningful information. Be it first moment, be it second moment, or third moment, or fourth moment, or graphical representation for that case. Be it histogram or box plot or scatter plot or any other plots that we have would work only if you have a numeric variable. And when we have a numeric variable, for example, in the project that we have dealt with respect to loan default prediction model, we had a column called as income. And when we looked at income, of course, we had age and the other variables as well. But when we have looked at income, we figured out that average income was approximately $8,000. Now, what do you infer from this as a standalone value? Right? So as a standalone value, there is nothing much that you can glean. The only thing that you can say is on an average income is $8,000. Until and unless we look at the second moment business decision, we don't know what is the variation in the data. Do we have someone with $2,000, someone with $20,000? And is it averaging to be $8,000? We really don't know that. So we had to do, second moment business decision also to understand the dispersion in the data with respect to the average, obviously. And then we really didn't knew whether we had any extreme values, etc. Hence, we resorted to box plot, right? So the point that I'm trying to drive here is that we cannot clearly delineate the data cleansing processes and exploratory data analysis steps. We cannot delineate these two. While you perform your exploratory data analysis, there'll be a lot of instances wherein you might want to come back to your data pre-processing steps. Maybe you want to figure out what are the outliers, how do you deal with those outliers, etc. And when we have done the box plot, we figured out that there were quite a few outliers on the lower extreme. And at the same time, we had outliers at the upper extreme, not too many, but there were. So what we could understand based on the data is that, yes, we have outliers. We ended up analyzing the outliers at the upper extreme because we had less data points. And we figured out that CEOs of a few companies and heads of departments were there. Their salaries obviously would be higher. But how many such people do we have in our data set? Right, was another question that we had looked at. So within the variables, we had another variable called designation. Then initially we thought, okay, can we only segregate the data based on designation and then do this analysis, exploratory data analysis? Then we felt that no, this is not the right way to handle. And then we have looked at third moment. In the third moment, when we looked at income, we have seen a skew towards the left side in the distribution. That skew was saying that, okay, probably there is a segment out here, segment of people who have low salaries. And these are the people who newly came out of the college. They were holding a banking account, savings account with the bank. Having said that, they had low salaries because they were entry-level employees in the various companies. So yet another insight. Then we resorted to kurtosis. And kurtosis, we looked at what is a peakedness, etc. Majority of the people, where do they fall at the central tendency? Is the central tendency very high? Or is the central tendency less? That means average. Is it very less or very high in comparison to the other values, in comparison to the variance, right? So we had to do all these kind of analysis, and ultimately, apart from that, we've also done exploratory data analysis of bivariate, two variables. We have taken two variables, and then we had done some scatter plots, etc. And eventually we figured out that income and education, while education is categorical, when we converted that into one-hot encoding, and when we have done a scatter plot, we figured out that education and income were having some interaction. Higher the education, higher the income, obviously. That's very common sense driven. So we felt that there have to be interaction variables also, which have to be included in further processing. So we multiplied these two columns, which is income and education, and we created a new variable. Okay, so I mean, that's how we progress further. We tried out both. We tried out label encoding also. We tried out one-hot encoding also to figure out what combination actually works well. So these kind of interaction variables are very important. Interaction variables don't just exist between two continuous or numeric columns. Interactions might exist between a continuous variable and a categorical variable as well. Of course, a categorical variable has to be properly encoded. And so, and also when we looked at the scatter plot, we did not have the provision to do a scatter plot for all the possible variables, but yes, certainly we have done it for a few variables such as age, income, and then we have looked at income and education by converting education into one-hot encoding, etc. And we could glean additional insights. Having said that, one of the other key takeaways was clustering. The skewness towards the left side and the huge variance and the presence of a lot of outliers in the lower extreme and a few on the upper extreme, all these things were giving away new insights that there could be presence of clusters. Because when we analyze the outliers at the lower extreme or the left tail of skewness, we figured out that those people, customers who were using the bank account were students. So there is a student community which existed. And when we looked at the outliers at the upper extreme, we figured out that they are CEOs of the company or vice presidents and above. So we felt that there was a lot of heterogeneity in the data. It was heterogeneous in nature. So we could figure out at that point of time that yes, probably clustering also makes sense. Okay. And then that was another insight that clustering is an algorithm that we might want to apply on the data set. And post clustering, once again, we have done EDA on each and every cluster to have appropriate descriptions to each and every cluster. So this is how we have done. Sorry for the lengthy response, but yes, exploratory data analysis would be lengthy. Significant amount of time we as data scientists will spend on that.
Thank you. Thank you, Barney. And audience, I'd just like to add further. So I'm sure all of you are aware, we are trainers and we are data scientists, and we do a lot of projects. So the reason why we get into this animated discussion when we talk about EDA, data pre-processing, and go on and on is we have actually worked in great length and spent a lot of time in these aspects. And trust me, as an interviewer, when you talk about EDA, I did first moment, second moment, third moment. In first moment, 4 variables had outliers. If that is your answer, trust me, the interview will know that you have done totally a bookish kind of a scenario. You have not got into the details. You must be able to tell a story around the EDA itself, right? So, and trust me, if you can actually impress your interviewer with the EDA, your rest of the questions are going to be easy. Don't expect an interviewer to, tell you, write the code, take a piece of paper, write this. particular code, write a loop function right now and tell me. It is not your college viva. It is a job interview. All right. So that is why even Bernie, for that matter, and we get so engrossed in that. I also like to add something more to EDA while we are on the topic. So the one more objective of performing EDA and getting those numbers is not to understand the numbers, keep it and forget. Now, when you visit your machine learning algorithm, and especially if you're working with supervised learning, the outputs, the results, the test data results that you get, you try to again correlate with these numbers, the EDA numbers, the average or the median or whatever, right? And you see, are these matching or is my model going way off? On an average or on the median, I'm supposed to get the output variable at this level, but my output is going somewhere. Something is wrong with my model. That is another insight you can always do. That this particular measures of EDA are something like a target that your model should be working around. So that is another insight that you can talk about it. So that is with reference to my take on that. All right. So we've discussed briefly about part of it in Barney's answer, but let me ask the question nevertheless. So Sharath, for you, what are the EDA specifically for categorical data? What kind of EDA do you do? And what are the insights that you can glean?
Yes, Nathan. So yeah, we get excited about EDA. Yes, definitely. And see, I also want to add one more point before I come to the answer of the question. We are data analysts or we are data scientists, right? That's the objective of your work. We are not going to become a Python programmers, or we are not going to become a mathematicians or a statisticians. So understanding your data and mapping it to your business and coming up with a story to explain the business conditions is something that should be on your top of your mind. So from that perspective, yes, definitely EDA is a very good armor for you to create that story. Right? So that's one more point I just wanted to add. Now, coming to the EDA with respect to categorical data, which is of course also known as non-numeric data. One thing we can do is identify how many categories we have. That means, for example, when I was working on my automobile project, one of the important categorical data was with respect to the engine type. So for these vehicles, different vehicles, if I had to identify the fuel efficiency, the engine type is going to be one of the crucial aspects. And when I look into the engine type, it is a non-numeric data, for example, petrol engine or diesel engine or electric engine, or you talk about a hybrid engine. So these are different categories that we have. So we need to identify what are the unique categories in the data, how many times each of this category is repeated. And from a business movement, if I have to talk about, the first movement, of course, can be calculated by looking at what is the value which is repeated maximum number of times. So it also tells me that from a business perspective, the business is inclined to this kind of a specific engine type vehicles. And it also talks me about the customers showing more active for taking the or procuring the vehicles which are of a specific engine type. Right? So this is basically how we can look into the categorical data. Of course, it is non-numeric, so we cannot directly calculate the variance or spread, but we can definitely look into the difference in the categorical counts, the value counts. And we can also do graphical representations to talk about the same thing. The maximum what we can do is try and identify the order or preference of these vehicles if we can form that natural order description for the categories. We call this as ordinal data. So that's basically how I can sum up to understand the EDA part of the categorical data.
Yeah, and just to add, friends, I don't want any repetition here, but Bernie already mentioned about interaction plots and interaction aspects with reference to categorical vis-a-vis continuous. So Sharath spoke exclusively categorical, but you can also look at it categorical versus continuous data, how the interaction exists between them and take that measure as well. So that's with reference to EDA. So I'd like to just open it for everyone here for discussion for the most unfavorite brothers among the 4 brothers. All right, that is brother kurtosis. So brother kurtosis seems to be, by the time we come to kurtosis, okay, we do that. So something we can discuss about kurtosis, all of us together. We can take our insights here because we have very little time. Yeah, please go ahead, Sharat.
Definitely. Kurtosis, yeah, definitely, which is one of the four business movements, which is not probably looked at with the same enthusiasm that we look at with respect to first and second movements. The third and fourth, of course, are also called as shape statistics, in right? A lot of books and a lot of people refer to that because they talk about the distribution. Now, whenever we talk about analytics, I would like to put it this way. The first movement business decision is speaking about the meaning of the data, the variable, when we talk about univariate data. The second, third, and fourth, the 3 business movements, the 3 brothers, they speak about the variation in the data. Now, when you try and understand what is different from what is expected, we tend to do that kind of analysis or root cause analysis to identify why something is different than what is expected. Now, kurtosis speaks about the overall variation in the data. If I take the entire data, is the data close to what is being expected, that is our mean, or overall is the data spread away? That basically tells me that there is a lot of variation. There's no consistency in the data. Now, to look at this, we of course talk about the visualization. We look at the peak of the entire data, and we also try and look at the tails, how heavier the tails are. This basically tells us about overall, right? The spread, basically, we're talking about overall spread in the data.
Yeah, another thing, because we are short of time today, another thing I'd like to add at this point of time is with reference to kurtosis, the interpretation of kurtosis. When you say a kurtosis is a very high value. So if I were to close my eyes and look at plus 17 kurtosis, you will see a very sharp kind of a peak that you cannot scale. When somebody says kurtosis is -4, you will see like a plateau. You will see a small hillock with a very flat top, like a bald man's head. You will probably imagine that. The disadvantage of this visualization is that kurtosis is interpreted thinking that the data is symmetrical. All right. So when I say kurtosis 15, you first consider or assume the data is symmetrical, which is skewness is 0, and then you look at the kurtosis, which is not the case. Kurtosis is something that can be measured for any kinds of data. If it is skewed, not skewed, it doesn't matter. You can measure it. But the interpretation of the value, if I were to say skewness is +9, you can immediately imagine a very long right tail. If skewness is -0.6, you see that the left tail is slightly longer than the other. This interpretation is absolutely correct. But in kurtosis, you assume it to be symmetrical and then make the interpretation. So that is another disadvantage with reference to the kurtosis, and that is why I would say a not so preferred cousin, but pure statisticians use kurtosis extensively. We have the 3 types of, the platykurtic, leptokurtic, mesokurtic measurements that is mentioned on our mind map. So yeah, with that, I think we will stop here.